All right, so again, today we're going to be talking about, this is the first lecture, there's two of them here, so we're going to be talking about schematics, prototyping, and soldering. Okay, so again, I mentioned this earlier, but schematic diagrams represent an electronic circuit in symbolic form. So a schematic may not need, it might not depict the actual physical arrangement of the component. So you have to think of it as like a symbol, and then the board is kind of the physical manifestation of all of those parts of what it looks like. But we have drawings to represent those actual items. And with the schematic, we're trying to capture how all of these parts connect to each other. So this is a schematic that you're going to be seeing next week. So I'm not going to go over too many details here with it other than to talk about some of these components that we saw last time. So we see there's a battery here. You're going to see things like a diode. We see these little, the resistors. There's a bunch of them on here. The 7556C is, and this other part are IC chips. And I see here there's a polarized capacitor. You can see that little plus sign. And then we also have some bipolar junction transistors, as well as a MOSFET. And then this right here, these are actually little symbols of how to read those out. And then we have a connector. So I actually have not seen this board yet because I'm fairly new here, but I just told you all of the main components that are on that board. So without seeing it, I could tell you what the functionality is, and without ever seeing it on. I should be able to look at this and have a pretty good understanding. And you can see here that there's a speaker hanging out here. I suspect that that speaker is not, maybe it's on that board, I'm not sure, but that might be something that's hanging off of the board. Anyway, so
This meeting is being recorded.
Okay, we're back. Sorry about the space aliens that have invaded our Zoom call here. Okay. So
Okay, go ahead.
Okay. We're going to move on to the next slide. Okay. Okay, so let's talk about how these wires are connected. So this is mainly talking about wires. So this line is just a single wire. And then when we have connected wires, ideally we see this little black dot. And this is really showing that there's a junction there. That's the way that I prefer to represent connected wires, because this other one, well, it does at least end in that single wire, but really the best way for people to understand that two wires are connected is through that junction. So you can see here they have C is definitely connected. We know that. And then on D, there is a little part that kind of, it looks like it's going around. So basically it's not connected, and we don't really know what's happening in E. So I tend to like only junctions are connected and then everything else is not. And that's typically when I look at, but every schematic you see, if it's not you making it, might be different. And then the different power sources that you see here are the battery, which I think you'll be seeing a lot in this class. And then the sine wave type thing is showing you an AC source. We probably should not see that so much. And then you're going to see maybe a DC source with the plus and minus. So this is polarized. Again, the battery is polarized. Also important, I talked to you last week about a common or a ground connection. And so there's different ways to represent this. One of those is an earth ground. That means that it is connected to maybe a wall ground, or sometimes you'll see on power supplies, there might be something called an earth ground, or you might see that symbol on there. The middle one is typically the one that I have seen for digital or signal ground. And then the chassis is like kind of the metal enclosure that might also be available to use. In general, I like to keep, if I'm using a digital circuit, that I'm not connected to earth ground. Ideally, that is the ground that I'm using is isolated from earth ground. And that's just because you can get those power spikes. It's kind of not the cleanest signal. So, and that may be something you can check on your power supply with your multimeter to see if that earth ground and your common ground is isolated. And you can do that with a multimeter to check the resistance between the two of them. And if you don't see a resistance, that means that they are, if there's no resistance reading or it's really high value, that means they're isolated. Next, we've got different, again, this is kind of a review from last time, these different types of resistors. And on the left, there's something called a potentiometer you might see, and that has, typically will have a little dial that you can change the resistance yourself. Or to the right, you see that line going through. This one here is what we call adjustable, and I would say that this is kind of like what the lamp was that you were using. It did change. We didn't adjust it, but it changed properties throughout that. So if I see that symbol, I know that that resistor value is going to be varying somehow. And then the capacitors that we're seeing, these two bars, again, I typically would like to see a plus sign when it's polarized. And then that line going through is, again, adjustable. I have not seen too many schematics with that symbol on there. This is the same thing for inductors and transformers. And the transformers typically are kind of back to back. So that's important to see that. And then typically it's just kind of this one right here that often I see. Diodes, we talked about these last time. The bar represents the cathode or the negative, and then this is the positive side. I tried to fix this slide to turn these the other way because I tend to like to see plus on the top of things and the minus or ground on the bottom parts of the schematic. So it's a little opposite here, but in general, the diode, and remember the light emitting diode, and then there's this, I have not used too much this variable capacitance diode, but I have used a Zener diode before. This is back to our transistors that we saw last time. If you remember, there are switches whenever one side of these is more positive, like in the NPN case. If this is more positive, up to, I think it's typically like 0.7 volts, and compared to this, then this becomes a short circuit from the top to the bottom. And then the PMP is the opposite. Typically these are the arrow, this is typically at the top, and then you need a more positive voltage than this area right here. And then the same thing with the N channel and the P channel. They work very also in a similar way. But these are all the different types of symbols you would see for them. The operational, so these are integrated circuits, you start to see that. You see the operational amplifier, you'll see a minus and plus. Sometimes there's also a version of the op amp that's just what we call a buffer. The signal follows that. Whatever you put in basically is out, but oftentimes there's a change in impedance, which might matter to a microcontroller. It's really important to think about that and understand how your, whatever the smart thing is that's looking at it, it might want to see a very low impedance or resistance. Impedance is another way to describe resistance. So if you hear me say that, that's what I mean. But then we also have these logic symbols. And so some of you may have been in programming, like programming classes, if you haven't seen these gates, where you've got like an AND or an or NOR, and NAND. So, and then typically when you see this little circle here, that means it's a negative or inverting. So if you had an AND, you don't have the circle. When you have a NAND, there is a circle there. So it's just switched the polarity. You can look these up if you haven't seen them. I'm sure at some point we're also going to be using them in the class. We'll go over them more. For switches and relays, there's the single pole, so this is physical relays. So whenever I talk to you about the transistor, saying that it's kind of like a switch, these are actual switches. So there is a mechanical switch that either opens or closes them. And there's usually a command that you will send, and then it will close this little, it's a physical closing of these little gates. If there's two, like, so this one only has an open or closed. In this particular one, we call this a double throw, where it can go into either one of these particular positions. And then you can also have the double pole single throw or double pole double throw. There's a bunch of different configurations that that people use, and you would use them for different reasons. And so, for example, like, why would you use a double pole double throw? Well, I've used this type of configuration before in order to use these top switches as a status on off, and then the bottom throw is used to transfer power. So basically at the same time you get a digital status that says I'm on, and then you actually in the bottom throw throwing passing power through. Again, those relays typically have a maximum current that can flow through it. Some of them are for signals, some of them are to route power through. Is really important to understand whenever you pick up a relay, how much current you're going to be wrapping through it. So there's many different ways that they have free programs to draw these schematics, different diagrams. So I would highly recommend, you know, go and practice with these things. Express PCB and Eagle are two of the free ones that you can use in order to do that. So building a prototype. So, you know, here we have the schematic, right? And now I don't want to go lay a board out, but I do want to plug all this stuff in and actually connect it and be able to do it. So there's a lot of ways to do this really inexpensively, and we're going to go over a few of them today. A few of these I actually have never seen before, so we're all learning together. So the breadboards, these definitely I've seen. I guess you can put it on a wood plank or whatever that is over there. That's pretty awesome. But typically the way that I see it is on the right-hand side. So these things have holes, and then you put the component, as you can see in the top, through these holes. And there are certain ways that these boards are connected. So typically when I look at this, like I would expect that, you know, some of these top rows here that I'm pointing to are connected electrically. And then typically along these columns here that you're seeing, they would also be connected. But each column here would not be connected to each other. So the way, if you ever pick up a breadboard before you just start throwing stuff on there, I would recommend taking your multimeter and then checking the resistance. And so if you're getting a low resistance across pins, that means that they're electrically connected. If you're getting an open circuit or no resistance, that means that those are electrically isolated. So you definitely want to have an understanding of how that breadboard is laid out before you were to actually go hook it up. So, and you can get those at any electronics store, anything like that. So they're very useful to hook up basic circuits. And this up at the top, that's actually a pretty complicated circuit. And you can also see how they have, what I like about it when I look at it is that there's some color coding going on for different things. And you can see, like I mentioned last time, it does look like they use black for ground, and then they use red for their power. So we clearly can see that on the board. And then maybe those other signals, some of them are commands, some of them might be, you know, digital inputs, different things. So it's nicely done. It's a good example. And also the breadboards, I should just mention real quick, it's very easy when you're hooking these things up to not push them all the way into the breadboard. And you end up getting like just your chip or something is not actually connected electrically to the whole system. So again, that's why you can use the multimeter to check those resistances, make sure everything is connected, and learn how to troubleshoot. This is probably some of you guys have in your kit today, the perf board or proto board. These things require soldering. So it's kind of the breadboard allows you to easily move things. This is a little bit more permanent once you start soldering, although it's still removable, but it just takes some more planning to do this. And you can see on the right that they have like kind of this white layer, silk screen layer here. And that's showing you that like those 3 pins are all probably connected to each other. And then the individual holes are completely isolated. And then you have the one on the left, which is what you might have in your kit. And that means that every single one of those holes is electrically isolated from the other holes. So if you want to connect them, you have to do it yourself. So this is one of those that I haven't seen before. I don't know if Josh, if you've seen this, but you have? Okay, cool. It uses little islands of PCB materials to glue to a substrate and ties points for components. So yeah, that's pretty neat and interesting. And then this is called a dead bug construction. Again, something that I haven't really seen too much. And let's see, the integrated circuits are flipped upside down with their pins sticking up into the air. Oh, interesting. Okay. Like a dead insect. While it's messy looking, it can be used to make more compact circuits than other methods. Yeah. Again, that looks like a lot of soldering, so it's kind of a more permanent way of doing things. Ultimately, though, if you have a design, you will probably want to do a board layout. And they're quoting here $300 per board. There's actually way cheaper versions now. I know Advanced Circuits is a board company that has a $33 special for, and it may even cheaper for educational purposes. So yeah, $33 per board for a 2-layer board, and for a 4-layer it's $66. So highly recommend them. I've used them throughout the years. And then this says, of course, the board drops rapidly when quantities exceed 25 or so. That's very true. Normally there's a cost break and all of that. So yes, go this route for final versions of things. So we talked a little bit last week about through-hole components and surface mount devices. Surface mounts are, they're very difficult to prototype surface mount components without a PCB board. So if you're trying to do prototyping, get the through-hole component, what's called through-hole, and you can look at that when you're looking at DigiKey or wherever you're ordering your parts from. You can solder the wires directly to the leads. This is talking about the surface mount components, but it's really difficult to do. And it's really best to just use the through-hole components whenever you're trying to prototype. So breakout boards, this is a way that you can have a little surface mount board, but then you can then hook it up to your, your larger circuit or to a development board. So like on the right here, this one looks like a development board to me that you can buy, and like there's probably some little things you can test on here. So like a vendor that makes these IC chips, they want people to use their parts, so they provide what's called a development board that already has a nice layout, and you can test all the functionality of it. And then if you want to add things, you can do something like on the left where this might have been made, but this might just be something that you can, it's kind of a generic with all these different hole patterns, and then you can solder wires from the two boards in order to make them together to get what a final circuit might look like, that you then take that design and then do a full board layout on it. So the two-terminal, so this is talking about two-terminal surface mount devices. There's resistors and capacitors. So just looking at this, I can tell you that I know that the left are resistors and then the right are capacitors. The size of these things really matter whenever you're ordering them. And there's different types, and some types are easy to solder and some are not easy to solder. So the larger ones are much easier to solder. And then once you get down to so this is like maybe a 1206, 0805, those are different types. But then once you get down to the 0603 or the 0402, you hand that to somebody and say solder it, and they are not happy with you. So it's best to like choose your component, if you're going to be soldering yourself. Now that little board that I showed you earlier, that had 0603 components on it. It's very small. And I got an external board manufacturer to solder all of those components. I did not do that myself. And in fact, the image sensor has pads on the bottom of the image sensor, so you can't even begin, like I cannot do it. You have to do it with a machine, a special machine that does that kind of soldering. So, but in this class, we're going to be wanting to use things that we can all solder ourselves, and either through hole or our larger size surface mount components. So, and then again, you can see that there is at least some writing on these. It may, this might be a standard with resistors. Typically, I know from a data sheet, and you can see the capacitors are just, we have no idea what values those are. And again, keep the packaging with the part, so that way you know what it is and you can go find out exactly what that value is. Hopefully it's printed on the package. So multi-terminal, okay, so this is like talking about integrated circuit chips. There's a wide variety of packages and footprints. And then there is somewhat of a standard though throughout the industry. And there's different types, and they just got some of them listed, like the small outline transistor, small outline integrated circuit. I have seen all kinds of things. So I showed you the little image sensor board earlier. So this ball grid array is, that image sensor is made like that, where the pads are on the bottom, so you can't even. So important point here is, if you order one of these things, make sure you know what you're getting and look at the package, because they may offer the same part in like 2 or 3 different packages. And get one that you are expecting it to be. Also, make sure that your footprint, if you do start doing layout, your footprint matches those the part that you're ordering. It's very important. So we're going to be doing a soldering tutorial. I'm going to do another PowerPoint here soon that's going to go through a lot of details on soldering. But when we talk about soldering, we are talking about fastening metal objects together using molten metal solder, which is solder, as the glue. And it's sort of like welding, if anybody has welded before, but it's on a much smaller scale. There's 3 requirements, which is the low melting point metal, the wire solder, the heat source, which is a soldering iron, and something we call flux, which prevents surfaces from oxidizing. So there's different types of solder that are used for different applications. Actually, didn't realize the silver bearing solder, the bottom one, was used for surface mount components. I've often just used the tin lead solder. There's different types, so just check on it. And they typically all tend to work exactly the same, with as far as you heat it up and then it starts to melt, and that's what you want. But there may be something hanging around your lab that's a low temp solder or high temp solder. So just again, check to make sure it's like a standard part that you're using. So soldering irons, and we're gonna again show you more details of this because this is what you guys are gonna be using. It's constant wattage, so the iron is continuously on and eventually reaches an equilibrium temperature. So that means when you first turn it on, it takes a few seconds to heat up to whatever setting you have. And then the tip, there's a tip on it that incorporates a thermostatic element to maintain the desired temperature. And that's a good range that they're putting there, 650 to 750 degrees Fahrenheit, which is appropriate for circuit board assembly. So apparently there's something really great on the next slide because it says even better, yes, is a temperature controlled soldering station, which allows you to set the temperature range and keep it at the desired temp. And it's adjustable with the analog dial, which is the one we're going to be using tonight. Or if you have a fancy one, there's like it's a digital display, which is also really nice. And then they have apparently a grounded tip to help prevent ESD damage. So that's what it looks like. That's what we'll be using. Maybe you have one now in front of you. So the different types of flux, there's different types in here. I'm not going to go through them because most soldering, most of the solder that you get actually has it inside of there. And so typically whenever I'm doing soldering, I just use the solder, that's it. And I don't add the flux to it. But there are reasons to do that you should check out before you do it. But in general, for most of the surface mount soldering, as well as the through hole, you should just be able to use the flux core solder. So there's 2 different types of soldering, and we've been talking about this. So this is an example of when I keep saying through hole, that means that the component has metal leads that goes through the board. And so you can see that that part is going through the board, and then you solder on the bottom of this board in order to hold that part in there. The second type is the surface mount. And so again, these are you have the PCB, and then you have the component on the top, and then the pads, what we're calling the pads, is where the component body and the solder all touch together. So there's kind of 3 components. There's the pad that's on the printed circuit board, then there's the component that has a metal part, and then you need the solder to intersect the metal part of the component to the pad, and that's how it stays on. And it not only kind of glues it on, but it electrically connects all those points together. So whenever you take your meter and you were to what we call ring it out or check the resistance, you should see that there should be very low resistance value between. It should be the same as if you touch the 2 leads together as it would be for you to touch across across one side of this component. All right, so we're gonna be doing this activity after I go through the second lecture, because the second one is actually has a lot more details about how to solder.